Hi, I'm Theo, this is Stanley, this is Aaron, and this is Aiden, and we did capsaicin as our molecule for the molecule project. So, just a little context for capsaicin, the Scoville scale. In 1912, a man named Wilbur Scoville decided to test the degree of spice in different kinds of spicy peppers. The peppers ranked based on the ratio of water to oil required to completely dilute the spiciness of the pepper. The oil, in this case, is capsaicin. So, for example, the Scoville scale starts at around 0. Something that's not very spicy, like a bell pepper, is at 0, while something like a jalapeno is around 5,000, and a habanero is around 150,000. The pepper that is said to be the hottest in the world clocks in around 1.5 million, and pure capsaicin itself is said to be around 16 million. So that's roughly a milliliter of pure capsaicin would require an entire hot tub's worth of water for it to taste not spicy at all. So just a little history on capsaicin. It was discovered by Christian Frederick Buchholz in 1816, but it wasn't the pure form. It wasn't until 1876 that John Claude Fresh extracted a nearly pure form of capsaicin, and Carl Micco isolated the substance in 1898. And the peppers originated in Central America around the Aztec and Inca civilization. After that short break, guys, welcome back.
Alright, so I'm going to talk about impact of capsaicin on society. So in popular culture, there's a show called Hot Ones, where celebrities eat hot sauces on wings, and they answer interview questions. It's kind of similar to what we're doing. There's also the spicy ramen challenge, where people eat a pack of ramen that has the same spice as one jalapeno pepper. And there are a lot of people on YouTube that are doing this challenge. With regards to cuisine, capsaicin was originally discovered in chili peppers, which came from Mexico. And the Indian long pepper also has capsaicin. It's the same genus as the chili pepper, but it's from India. And North Indian food is really spicy, characteristically because this spice prevented food from spoiling. And the bacteria couldn't survive in hot environments. So capsaicin also kills up to 75% of bacteria. So there's a relationship between how hot the climate is and how spicy the food is of the culture. Also in modern day, we use pepper spray a lot. And the active ingredient in pepper spray is capsaicin, the capsaicin is extracted and mixed with an emulsifier and then used in aerosol. And the pepper spray affects the eyes and the nose and the mouth, pretty much every orifice that you have. And the strength of pepper spray is difficult to gauge because it depends on how you extract the capsaicin, and there's no real regulation to it. Oh my god. And pepper spray or capsaicin is also banned in equestrian sports because it's pretty much a painkiller for horses. And in these 2008 Summer Olympics, 4 horses were tested to be jacked on capsaicin, and they were disqualified because of it.
So I'll be talking about how capsaicin is obtained or synthesized and why. So first of all, capsaicin wasn't synthesized until 1930 by E. Spath and S.F. Darling. You basically have to take a capsaicin synthase, an enzyme, and multiple intermediates, and then react them with all those intermediates until you eventually get what we know as capsaicin. Capsaicin, on the extraction side, can only be taken from the pepper genus because the capsicum genus is only found in peppers. The way that capsaicin is obtained directly from a pepper is basically just by mashing it, combining it with rubbing alcohol, and then straining it so you get out all the plant material, and then boiling off all the alcohol so you're left with pretty much pure capsaicin. Although it has never been taken in its pure form straight from the pepper, it's expected to be clear when it is, although it usually comes out red. Once you have capsaicin synthesized or obtained in its almost pure form, there are a whole number of medical uses for it. The two most popular are in patches and creams. So if you rub it on your skin or apply it to your skin, capsaicin can relax the arteries as well as lowering blood pressure. Creams for topical pain can relieve minor aches and joint pains from certain joint conditions, as well as muscle sprains, strains, headaches, and migraines. And some research even suggests that it can help improve scaling, inflammation, redness, and pain from psoriasis, or even pain from nerve damage due to shingles or HIV.
So, like Theo said earlier, you touched upon the molecular formula, and in this molecular formula, some of the functional groups are phenol, ether, an amide group, and an alkene group. So the reason capsaicin hurts when it gets in your eyes, or your mouth, as we know, it inflames mucous membranes, causing a burning sensation to rise, and gastric juices to be secreted in your stomach. This is why it really stings when you go to the bathroom after a spicy meal like a curry. It also triggers a large release of stress hormones that causes reddening of skin and sweating, like we saw with Stanley. It can also trigger the flight or fight reaction in the body, which causes your heartbeat to speed up, quickens your breathing, and even causes your body to start burning fats for energy. So touching upon the more scientific side of what Aaron talked about, there's a protein called TRPV1, which is responsible for sensing heat. It's on the outside of cells, and so when you touch an iron, it sends signals to your brain, like a hot iron. It sends signals to your brain to send pain to that area. However, capsaicin molecules can bind to this protein chemically, causing the same effect as if you were touching, say, a hot iron. However, there are not many cases of physical problems actually arising. The TRPV1 protein receptors can be weakened from repetitive use, so uses like pain cream, like Aaron said, in small doses can weaken the receptors and lower pains from other things like arthritis. Since capsaicin has a long hydrophobic tail, it easily binds to TRPV1. Since this hydrophobic tail, you good? Since it has a long hydrophobic tail, water doesn't help at all. It actually makes it worse. So since dairy products contain both fats and proteins, it can soothe the pain caused by the molecule. And since it contains casein, which is a protein, milk contains casein, which is a protein that can actually bind to capsaicin and pull it off of the molecular receptors, the protein receptors on your cells, surrounding it and relieving the burn.
So, ladies and gentlemen, this has been our project on capsaicin, or C18H27NO3. We hope you enjoyed. Stay tuned for a bonus round where you can guess which pepper all of us ate. Thank you for watching.
I ate a jalapeno pepper. Its Scoville scale is around 5,000.
I ate a sweet vine pepper. Its Scoville scale is around 0.
I ate a serrano pepper. Its Scoville scale is around 25,000.
And
I ate a habanero pepper, its Scoville scale is around 150,000.
It still burns.
Dude, the milk helps for like 2 seconds, and then it's like I just ate it again.
Yeah.